Hi friends, is my voice is audible to you? If my voice is audible and if everything is fine, please let me know. Is that okay? Right. Let me just check. Okay. 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 Let me just check here. 1 second. Okay. Right. Okay. I think my voice is audible to you guys, right? Right? Hi Vasan Sai, hi, how are you? Is my voice is audible? If my voice is audible and if everything is fine, please let me know. Right? Okay? Right. Today's the session is topic is on summary of IS 800 part 4. In this one, we will deal with old code of practice codal provisions and new code of practice codal provisions. Mostly we'll work out about old code of practice questions only, because limit state method I already completed in your previous sessions. Like 2 months before, I had completely screwed up the entire limit state methodology of designs and its problems in detail. I had covered. So major emphasis is on working stress method, but we will match both working stress method and the limit state method. We'll compare both, and we will try to solve the problems in some specifications. Okay, right. Okay, before I start the session, I just want to convey today, in today's session, I will talk about both compression member specifications and beam specifications in this today's session, right? So using multiple choice questions, I will talk about the specifications of these both. So before I start the session, I just want to say big hi to all of my brothers and sisters who are on the online. Hi, how are you guys? Hope you are fine, right? And everything is working well for you. Uh, I want to convey, like, there is so much of free content is already happening in this Unacademy learning gap. So if you are a serious aspirant of GATE or ESE or any other competitive examination, I can definitely recommend you guys to install this Unacademy learning app and enjoy at least the free content, right, which is getting delivered, right? So some people will also ask us, sir, how we can follow you in Unacademy learning app. Using this link which is given below, you are able to follow me. With the help of this link, you are able to follow me. Press over this link after you install the Unacademy learning app. Type this link, okay? And after you type this link or press this link, it will you guys will be redirected to my page in Unacademy learning app. Okay, right. Some people will also ask us, sir, is there any paid courses are there in Unacademy learning app? Yes, in Unacademy, after you install the app, you select the targets itself as the examination, whatever you want to crack. We want to crack GATE and ESE, no? So you can keep that. If you want to crack state PSU examinations, you can keep that. It's not at all a problem. After you select that one, so you in the main tab, go to main tab. In the main tab, you go to plus courses. After you go to plus courses in the main tab, you can use this terminology called as get subscription. Get subscription is the thing that you are interested in paid course. In paid courses, there are two types of paid course. One is plus course and the other one is iconic course. Right, in this plus course you will have four advantages, like you will be given with instant doubt resolution directly with the mentor, and you can after writing the test series, you will know at what performance you people are. You will be given with the test series support also. And the third one is all the courses of Unacademy are completely structured courses. If you follow the plan that is provided by Unacademy, definitely we are pretty much sure like you are able to crack any sort of competitive examination, that is for sure. And fourth one is unlimited access to the lectures will be provided, even though if you are not able to attend the class in the for live session, you will be provided with this unlimited access to the lectures in the form of recorded version. So all these are the four advantages when you had taken the plus course. To take the plus course or iconic course, I can say you to get 10% discount for any of the paid courses, I can definitely say you can use the referral code VT10. When you are able to use the referral code VT10 directly, 10% discount will directly come to you on all the courses in Unacademy Plus or on an Iconic. Okay, so coming to Iconic, it is just like that of Plus only, but additionally two additional things will be there. So the first additional will be you will be given with a personalized mentor. So he will track your performance and he will report your performance and he will take care of your entire complete doubts. And the sixth one is, so in case of sixth one, you will be provided with a separate exclusive topmost notes that is provided by an academy separately. This is the sixth use. So Iconic is more I'm extremely sorry. Iconic is more sophisticated than this plus course. So you can take either plus course or Iconic course depending on your requirement. For any of the course to get 10% discount, you use this code VT10. Right. When you had taken this paid course, you will be taught by India's topmost faculty, and there is no need to go to Delhi, Bombay, or Kolkata, brother. So all the topmost educators of India are directly right now available at your doorstep by using the single code VT10 through Unacademy. Right? Okay. Some people will say, sir, this is my first class. Please introduce about yourself. I am Venkata Tilak Kopalapati. People call me as Venkata sir. Some people call me as Tilak sir. I completed my master's degree from University of Sheffield, England, and about to complete my doctoral degree, PhD also. My background of education is completely into structural engineering. So here also in an academy, I am going to teach only the structural engineering subjects. So coming to this university from where I had graduated, this university has produced six Nobel Prize winners. You can understand producing six Nobel Prize winners from a university is not a joke. You can understand the depth of research potentiality involved in that university, right? And moreover, I can also say like this university ranking is always far better than IITs and IIC Bangalore. Global university ranking of this university is always less than 100, which is far better than IITs and IIC Bangalore. Brother, I don't have any partiality. It is not told by me. It is advocated or supported. It was told by almost all the ranking agencies in the global world. Okay, right. And some people will say like, sir, what is your previous work experience other than teaching? Previously I worked as research scientist or research engineer in University of South Carolina for a funded research project. This is in USA. For the same research project I worked as a team leader, also team lead, right? And in addition to this one, previously I worked as head of the department of civil engineering for an engineering college. This is in India. This is in Andhra Pradesh, India. Right. So coming to my teaching experience, previously, totally I have 12 years of teaching experience in different coaching institutes all across India. Especially, I taught GATE and ESE in different coaching institutes. Right. Being a structural engineer, even till today, also I am working as an independent structural design consultant. I personally give structural drawings to my clients, and I personally give material testing reports to my clients, brother. This is my brief background, bros. So some people will say, like, sir, you asked us to install the Unacademy Learning app. Now, how to install the Unacademy Learning? That is the first question. Go to Play Store, and after you go to Play Store, type this name Unacademy Learning app. When you press enter, you are able to see a icon in this way, a cup championship type of trophy. That app you install, after you install that app, you are able to see a screen on the right hand side in this way. So this is the main tab. This is called as main tab, and this is the goal what you want to achieve. Here the goal that you want to achieve. Keep the goal, whatever may be the goal that you want to achieve. Goal you want to achieve. All right, and this is the search button. Right. So the question is, I hope you know how you install the Unacademy Learning Gap. Second question is, sir, how we can, so everybody will say like, sir, how we can follow you, sir. So the question is, how we can follow me is, so go to this main tab and press free classes. After you press free classes in the main tab, in the search button, you type, after you type free classes in the main tab, in the search button, you type my name, Venkata Tilak Uppalapati. When you type my name Venkata Tilak Uppalapati, and if you press enter, my profile page will be visible to you. When my profile page is visible to you, you just follow me. When you are able to follow me, the advantages I had already mentioned. What are the advantages? The already the free content done by me in Unacademy learning app, you are able to follow. That is the first advantage. Second advantage in following me is the future coming free video lectures of mine in Unacademy learning app will be notified to you. That is second advantage. Coming to third advantage, at the end of each and every special class, we will provide a notes in the form of PDF that you are able to access. All these three are the advantages which is are for free of cost when you are able to follow me. Right. Some people had a question like, sir, how I can say how I can take the paid course. So in the to take the paid course, you go to plus classes here, plus classes or courses. After you go to plus classes or courses here in this sorry, you go to plus classes, you are able to see the terminology called as get subscription. When you had taken this get subscription, definitely you are able to redirect to the payment page. Before it is redirecting you guys to the payment page, you can get 10% discount by applying the code. So here in between these two, I can write apply code VT10 to get 10% discount, and it will be redirecting you to payment page. You can pay the payment in installments or at a single payment. So depending on your easiness, you can do installment payment or you can do single payment. And the payment for a course depends on the duration of the subscription that you had taken, right? This is how you can do, brother, right? So these are the advantages that I had already teach you why if you had taken the paid course, right? And these are some of the topmost indicators that we have directly. You can have a directly look at the app. And I want to convey the course will be taught separately in English and also separately in Hindi. So there won't be any language barrier for you guys. So those who are comfortable in English, they can attend English classes. Those who are comfortable in Hindi, those guys can attend the Hindi medium class, right? So some people will also ask us, sir, till now in GATE and ESE, how many courses you people had launched? Till now in GATE and ESE, we people had launched almost eight courses. Out of these eight courses, few courses are long-term courses, few courses are short-term courses. Few are, I can say, in English, few are in Hindi. When you had taken the subscription, you will be provided access to all the courses in that particular stream that was launched by Unacademy. As a pool of faculty are going to get add up every month. So for every month, at least one more course extra will get add up. Even you will be given access to those courses also within the duration of subscription that you had taken. Right. Now coming to the price. So if it is a 12-month subscription course, in case of Plus, in case of Plus platform, the cost is after 10% discount is 27,225. I can recommend this 12 months course for the students who are in final year. If you guys are in third year or maybe I can say second year, then I can definitely recommend you guys this 24 months course. The cost of this 24 months course is 39,600 after 10% discount. So for any of the course from 1 month, for any of the courses from 1 month subscription to 24 month subscription course, to get 10% discount, you are bound to use this code VD10. There is no need to go to Delhi, Bombay. All the things are right now directly available at your doorstep. Shashi Comet Reddy, sir, one doubt you have in IS or in Fillet World, we have to calculate F equivalent and F resultant code is F1 plus. Okay, Shashi Comet Reddy, I will work out. I will work out that one. I will tell you. Just let me complete. Give me a couple of minutes. It will be completed this speech, and after that I will come to your doubt. Don't worry, Shashi. Okay, right. So and every day my class is happening by 11 a.m. So don't forget to come down to my class and subscribe to this Let's Crack GATE and ESE Civil YouTube channel so that you will not miss even a single class also, brother. And I can recommend you to subscribe to this Let's Crack GATE and ESE Civil YouTube channel. right? And don't forget to press the bell icon. If you press the bell icon, the future coming videos will be notified to you. One thing. And please raise a thumbs up for our videos. Please like our videos. Please share our videos, because for you are getting all this for free of cost. You, if you are able to share these videos to your friends, they will also get benefited. They will also, there is no need to pay anything for this free content. Na? Like that, you are helping your friends also. And moreover, I can say, like, subscribe to our Let's Crack Gate and Gate and ESE Civil YouTube channel, Civil Telegram group also. You can even subscribe to this one also. And another Telegram group channel is Unacademy _ Civil Engineer Tilak. You can even follow this Telegram group also by hitting the link which is given below. Okay, right. So let me start the questions, brother. So okay, Shashi Komet Reddy, in IS 800, one thing, in IS 800, if you are talking about Shashi Komet Reddy, will you allow me to switch on the fan, because the power has gone? If you just allow me to switch on the fan, just after half minute, I will start teaching you the thing. Okay, right. I will clarify you. 1 second, brother. Right, Shashi Komet Reddy, thanks for your patience, brother. Okay, I am coming to your doubt only. Yes, okay, thank you. Right, okay. So what Shashi is asking, like, sir, in IS 800, shall I use resultant, F resultant, or shall I use F equivalent? That is the question. Dear brother, I just want to say, like, here the code has mentioned the resultant stress you can take as directly. There are two cases are there. One is when weld is acting within the plane of, when the moment is acting within the plane of weld, when moment is acting within the plane of weld. And there is one more case, when moment is acting out of the plane of the weld. Out of the plane of weld. So when moment is acting within the plane of weld, you will work out the resultant stress or equivalent stress. Both are one and same in our terminology. Okay, please understand, which is F1 square plus F2 square plus 2F1 F2 cos theta. This is the thing. When you had come to when moment is acting out of the plane of the weld, in this case, we need to work out, there are two stresses are there. One is normal stress, I can say, one is tensile stress Ft, and or maybe normal stress F, another one is shearing stress. In this way, there are two stresses are there. Here in this case, when it is acted with F and Q, as per new code of practice, there are two things, brother. You are getting deviated. So as per new code of practice, as per IS 800 2007, you need to take the resultant stress or equivalent stress, whatever that may be. That is the resultant value. The angle between F and Q, both the nature of the stresses are different. Listen. Nature of stresses are different. When nature of stresses are different, you cannot directly write square root of F square plus Q square. Square root of F square plus Q square you can write when the nature of stresses are one and same. But here the nature of stresses are different. Na? So in such case, as the nature of stresses are different, as per new code of practice, you are bound to take that resultant stress or maybe the equivalent stress. Any terminology is one and same. In such case, you need to take it as F square plus 3Q square. Why there is 3 is inserting? Because the nature of stresses of F and Q are not same. One thing, as per old code of practice, as per old code of practice, when as per old code of practice, if FEQ, it is taken as square root of F square plus Q square. This is as per old code of practice. It was not correct, but here I can say this is IS 800 1984 code, right? Yes, sir. I am saying out of plane only. For out of plane, I can say as per new code of practice, use this one. As per old code of practice, use this one. So I that's the reason I didn't get the clarity. So everything I had discussed. This equivalent stress or maybe the resultant stress, whatever there may be, as per old code or new code. Generally we will use the new code. As per new code, this value should be less than or equal to permissible strength of the weld. What is the permissible stress or design stress of the weld? The design stress of the weld is ultimate strength of the weld by root 3 into 1 by factor of safety. This is as per new code, this is as per old code. So depending, when they say the terminology called as permissible stress, you need to use this old code. Old code in sense working stress method. In the new code in sense as per limit state method. So whatever may be the exact question that they are asking, depending on the question, shall you need to use the new code or old code? Depending on that one, you need to apply the equivalent stress or the resultant stress, brother. Is that okay, Shashi Kobetreti? I had clearly mentioned you the difference between these two. Is that okay? Right? Right. Right. So can I go to the next question? I mean, shall I go to the actual problem? Is that okay? Right. 1 second, brother. Right. I hope are you able to see this question, brother? In ISMC, Indian Standard Medium Channel, 400 channels placed back to back at a spacing of, so ISMC 400 channel is there. There is another ISMC 400 channel is there. The depth of the channel is 400. It's not at all a problem. 400 millimeter, and the spacing of these two channels is 26 centimeter. So I can say this is 260 millimeter. In such case, this built up column is able to carry an axial load of, it is able to carry an axial load of 160 newtons. So axial load P is equal to axial load acting on the column, built up column, 160 tons. So as that lacing system should be designed to resist a transverse shear. So what is the lacing system should be able to resist a design shear? In case of, there are two things. In case of old code of practice, as per new code, the concept is, I mean, the formula is one and same. It is the lacing system shall be able to resist a transverse shear. I can say we transverse shear is 2.5 percentage of total axial service load here. Here it is 2.5 percentage of total axial. Here it is the factored load. That is the thing. So if I work out with respect to old code, 2.5 by 100, what is the service load that is acting on the column? It is carrying an axial load of, carrying an axial load means it is the service load. It is carrying, it is taking that load. So it is 160 tons. This is as per old code. If it is as per new code, I can write 2.5 by 100 into total factored load is service load or characteristic load into 1.5. So it is 160 into 1.5 tons, like that. If you work out as per this old code of practice, the answer is 4 tons. If you work out as per new code of practice, it is 6 tons. Definitely there is no option of 6 tons is there. Then you can pretty good understand like this is as per old code only. So the option is only directly 4 tons, right? Because in old code it is as per working stress method. This is as per LSM, limit state method. Okay, shall I move to the next question, dear Shashi Komet Reddy, or all the persons who are on the online, brothers? Can I move to the next question, brothers? Okay, yes, moving to the next question, brothers. Which one of the following is not a compression member? So you tell me which of the following is not a compression member, brother. Strut is a compression member in case of a roof truss. Compression member. This is a compression member. Tie. What do you mean by tie? Tie is a tension member. Tension member in a roof truss. Right? Rafter. Rafter is the principal compression member in case of top chords of a roof truss. Principal compression member. This is also a compression member. Na? Boom. Boom is the major compression member in case of a crane system. Major compression member in case of a crane system, na? So you should understand like the correct option is not. Not a compression member is, the The option is only B for Boston should be the correct option. It is not a compression member. It is a B is the tension member. Na? So directly I can pick option B. Is that okay, Shashi Komat Reddy? Brother, right? So can I move to the next question, brother? Shashi Komat Reddy or other persons, other brothers who are on the online, other sisters who are on the online. Shall I move to the next question? Moving to the next question. So can you see the slenderness ratio of splices of compression members? So if you take splicing of compression, splicing means joining of compression members. If you take, if this is a compression member, right, and if you take, there is another compression member, these two compression members should be attached axially. For that one, we generally use the terminology called as splicing or joining. If I join these two columns with the help of some plates, what is the slenderness ratio for that splicing? Generally, one column is kept over the another column. Now there won't be any gap. After that, we will provide this bolts maybe in this way. So the distance between the two bolts are very, very negligible, and there is no buckling action will takes place within this connection. As there is no buckling action is coming within this connection, so I can say like almost, if you take the slenderness ratio, there is no effective length between these two bolts. Almost one bolt and another bolt are very, very closer. And I can say definitely in such case the slenderness ratio of splicing elements, the slenderness ratio of compression splicing elements is almost 0. So directly I can pick option A. This is as per old code of practice, right? So can I move to the next question, brother? Right, moving to the next question. I hope you are able to see the next question. Two ISMC are placed back to back at a spacing of 300 millimeter. Okay, same thing is carrying an axial load. So the load coming on the column is I can say 160 kilonewton. As per ISA 800-1984, that is as per old code of practice, its lacing system shall be designed to resist a transverse shear. What is the transverse shear that is resisted by lacing system? This I had already mentioned. This type of model, 2.5% of total axial load. So which is 2.5% of 160 kilonewton. So if it is 2.5% of 160 kilonewtons, 2.5 by 100 into 160, you will end up with the kilonewton called as 4 kilonewton. So this is as per old code of practice. Those should not multiply with by 1.5. So the correct option is B for Boston will be the correct option. This I had already worked out this type of model just before also. Right. Moving to the next question. Can you see this question? Permitted maximum slenderness ratio of steel column under dead load and live load condition. So I hope you know the maximum. Before I give this slenderness ratio limits for different types of compression members, maybe I just want to write here the condition I can say. Here this is the condition and this is the limiting slenderness ratio. So maximum slenderness ratio on steel column under, so the condition, the type of load acting is load acting on column is column loaded by dead load plus live load combination, or just dead load or live load. In such case, the limiting slenderness ratio is 180, and the column or compression member is loaded by compression action because of lateral loads like wind load and I can say earthquake load and all this stuff, right? So in such case, sir, can you please repeat? Biank Sharma, sir, can you please repeat question number 40 of part 2? Question number 40. You are saying this question number 40, man. There is no question 40, brother. Dear Biank Sharma, the question number is 103. Dear Biank Sharma, have you seen this? Yes. How we determine the direction of resultant stress? Okay. So how to determine the direction of resultant stress? Okay. 1 second. Mhm. Second. So the direction of resultant stress. Part 2. Dear, I doesn't have anything right now available with me that part 2. But question number 40 you are asking, but I don't have right now that question number 40 with me. But anyway, I can say to you, dear Bianca Samantha, like what is the question? If you name that question, definitely I will solve you, because that part number 2 doesn't have right now with me. I cannot go back and I cannot check. If you ask me like how you are asking how to determine the direction of resultant stress. The direction of resultant stress, in which case are you expecting me in case of weld? Are you expecting me in case of bolts, or how? So can you detailedly type that question? Maybe you are saying about are you talking about bolts or rivets, or are you talking about weld? In weld, if you are talking about the direction of resultant stress, maybe in weld there is a thing like when moment is acting within the plane of weld. When moment is acting within the plane of weld, when this is how the column is, for example, this is how the what I can say bracket plate is, and these are rivets, maybe 1 2 3 1 2 3, these are the rivets, maybe you are talking about this one. So in this case, when I apply an axial load P, this is the CG of the rivet tube, so the reaction force P will go through in this way. So if you take what is the axial force that is developed in each and every member, the axial resisting force in each and every member is, so each and every, there are 6 elements are there. This resisting force P is resisted by 6 rivets. So I can say P by 6 is the answer, which we people called as FA, or maybe F1 we can talk. So because of this P at P with some eccentricity E, right, there about this axis, the moment or torsional moment T or M, certain moment called as PE is acting. That PE, because of this PE, that is a torsional moment, na? Because of torsional moment, the rivets or bolts will be subjected to shearing stresses only. Coming to the direction of the shearing stress that is coming into picture because of this torsional moment, in which bolt you want to work out the shearing stress because of this torsional moment. Draw a radial line from the CG of the bolt group to that bolt. So normal to the direction of this line, the direction of the shear force will happen. This is how the direction of the shear force, because this angle should be 90, and as the applied moment is clockwise, the resisting moment because of this shearing stresses should be trying to develop an anti-clockwise moment. So that's the reason why it should go upwards. And coming to that shear force due to moment, maybe which call it as F2. F2 we can write as M into Ri by sigma Ri square. So this Ri, this is first bolt, second bolt, third bolt, fourth bolt, fifth bolt, sixth bolt, right? So bolts are in 2 by 2 rows, and column was given and asking all bolts will be highly stressed. This is the case, brother. This is the case. I hope you are able to, I am saying the same question. Okay, maybe instead of 2 bolts there are 6 bolts are there. Which bolt will be stressed more? The bolt which is farther from the CG of the bolt group will be stressed more. How you can say as F2 is equal to M into Ri by sigma Ri square. Ri is the radial distance of the bolt in which I or you, okay, in which I want to find the shear stress, shear force. I cannot say shear stress, shear force due to torsional moment. So in such case, that is Ri. So how many bolts are there, brother? 6 bolts. So I can say sigma, I can write I is equal to 1 to 6. Is that okay? So which bolts will be, I hope you know, when you take a circular section which is subjected to torsional moment, what the torsion equation will tell you. The torsion equation, the torsional stresses are more at the extreme fibers or at extreme radial distance. So if you take, this is the extreme layer, this is how the shearing stresses values are maximum at the extreme layers, and it is 0 at the centroid, right? So here the shearing stress is 0 at this CG of the bolt group, whereas it is maximum at the rivets where it is higher radial distance from the CG of the bolt group. The higher radial distance from that are existing for the CG of the bolt group is first bolt, third bolt, fourth bolt, and sixth bolt are having high radial distance. High, can I write this as high radial distance from the CG of bolt group. So out of 1, 3, 4, 6, any of these are possible. And there is one more question, one more condition is also there. The bolts will be stressed more when the distance of the bolts are very farther from the CG of the bolt group. That is one thing. And when the angle between the two forces FA and FA, F1 and F2, and the angle between the two shear forces is less. This is theta. How to work out the direction of this resultant resultant shear force, brother? If this is F1, brother, I hope you know this is F1. This is F2. You know F1 and F2. You know the angle between these two, F1 and F2. How we can find out this angle between these two? Maybe I can say if I draw a line clearly with the help of this horizontal here, whatever may be the theta here, the same theta will exist here. So when this is F1 and when this is F2, what is this resultant force direction? This resultant force Fr is square root of, we can write as F1 square plus F2 square plus 2 F1 F2 cos theta. Dear brother, for especially Bianca, Samantha, this type of questions I had already worked out. I had all this type of questions I had already worked out. This type of question I had already worked out 2 months before in detail. I had screwed up entire connections. So please, 1 second, brother. Take one picture. ఆ లైట్ వేయొచ్చుగా ఎందుకు ఊరినే వచ్చేట్టు సారీ బ్రదర్ sorry about this. Yeah, so when you take these four bolts, out of these four bolts only few bolts will be subjected to a higher stress. The angle between F1 and F2 is less, such bolts will experience higher stress. So if you take this, maybe if I rub the screen, shall I rub the screen? Is that okay? Maybe I may use another slide here. So there are six bolts are there. You take this is CG 1, 2, 3, 4, 5, 6. Is that okay, Samantha? Right, Bianca, Samantha. Right. So this is first bolt, third bolt, fourth bolt, sixth bolt. The angle between F1, this is F1, this is F1, this is F1 in fourth bolt, this is F1 in sixth bolt. Right. Is that okay? And how to work out the direction of F2, the direction of the shear force that is coming into picture because of torsional moment? Draw a radial line from the CG of the bolt group to that radial line. That shear force will act perpendicular to the direction of the line joining this line joining this radial line, right? So for this radial line, what is the perpendicular direction? This is the perpendicular direction. This is the direction of F2, and the applied moment is clockwise now, so direction of this resisting force should be anti-clockwise. So coming to this is the radial direction R. So the direction of F2 in this case is F2 in this way. The angle between F1 and this radial F2 and radial direction is 90 degrees. The angle between F2 and this radial direction is 90 degrees. Similarly, this is the line that has got joint, right? Is that it, brother? To this line, this is the direction of definitely I can say it should be divided in anti-clockwise now. So if this is the line, so how it should, the F2 should direct, this F2 should be going in this way, so that it is trying to rotate in anti-clockwise fashion, which is opposing the applied torsional moment. T is equal to T is equal to P into E, which is equal to M, right? So if this is the radial line, to this radial line the resultant the the shear force should try to act at 90 degrees to this line joining this radial line. So this is the direction of the shear force, which is trying to rotate in anti-clockwise direction. I hope you are able to find out the angle between F1 and F2. Here this is F1 and F2 angle. Here this is F1 and F2 angle, which are high. Whereas in these cases for first bolt and third bolt, the angle between F1 and F2 is less. As the angle between F1 and F2 is less, if you know the resultant force, it is square root of F1 square plus F2 square plus 2 F1 F2 cos theta. To get Fr as maximum resultant stress, theta should be minimum. Then only I will get resultant stress as max, because Fr is a function of cos theta. Cos 0 is 1, whereas cos 90 is 0, cos 180 is minus 1. So as theta is keep on increasing, should be, the Fr should be, to get Fr is max, theta should be minimum. Theta should be minimum. So in which cases we are getting lesser theta. In the case of first bolt and third bolts only, we are getting, I mean, first bolt, see, first bolt and third bolt, you are both, first bolt and third bolt are at same radial distance, right? Same radial distance. First bolt and third bolt are at higher radial distance. Moreover, first bolt and third bolt are satisfying lesser angle of theta between F1 and F2. So first bolt and third bolt, both will be stressed more, right? The answer is first bolt and third bolt will be stressed more. Is that okay, Bianca, Samantha? Is that okay? Answer is first bolt and third bolt. Both. Okay. So can I uh, rub this one? Yeah. So if you come down to this question, I hope you had came down to this question. Now, for this question, you tell me what is the answer. Okay. Yeah, for you guys only we are doing all this, brother. Don't worry. Okay. For you guys only we are doing this. Right. Don't worry. If you had any doubt, you are free to ask, brother. Right. For you guys only we are doing. Right. Yeah. So when column is loaded by dead load and live load, in such case the slenderness ratio is 180. Some people will come and say like, sir, the column is subjected to load. Column is loaded by earthquake load plus wind load. In such case, it is given by this 250. This is how you can take the limiting slenderness ratio for columns. So for limiting slenderness ratio for columns, the permitted maximum slenderness ratio of steel column under dead and live loads. Under dead and live loads, it is 180. Na? So directly you can pick option A for Amsterdam is the correct option. Directly A for Amsterdam is the correct option. Is that okay? Yes. Shall I move to the next question? Yeah. Right. Can you see this next question, brother? Bianca, Samantha, Shashi Komat Reddy, or any other person who are on the online, brother? Yeah. The thickness of the lacing bar for single lacing system. The system of lacing is single lacing system, brother. I hope you know when this is a column and this is a column, right? I mean, these are two rolled sections. These two rolled sections are tied together with the help of lacing system like this. With the help of single lacing system in this way, these were tied together. So with the help of single lacing system, this was tied together. The question is, if this is a lacing bar and a lacing bar in case of single lacing system, lacing bar in case of single lacing system, in such case, the thickness of the lacing bar, what is the thickness of the lacing bar? Thickness of the lacing bar should always be less than or equal to, thickness of the lacing bar should always be less than or equal to effective length of the lacing bar, or I can say indirectly, I cannot say effective length between a inner end of the connections. So the length of the lacing bar by 40. This is the codal provision as per both IS 800 1984 and as per IS 800 2007, in both of the code of practice, the thickness specification for single lacing system is should always be, so not always be less than, should always be greater than or equal to L by 40. So minimum this thickness is required. This is the minimum thickness of lacing bar, minimum thickness of lacing bar. Now coming to the, some people will say like, sir, if the system of force, if the system of lacing is not single lacing system, sir, these are columns and this is how the lacing system is in this way. I hope you are able to. What is this type of lacing system, brother? This type of lacing system is double lacing system. In case of double lacing system, I can reduce the thickness. Why I can reduce thickness? So here the transverse shear can be resisted by two two lacing elements at a time. So in such case, for every lacing element I can reduce the thickness. So coming to the thickness, minimum thickness of lacing bar in case of double lacing system, this is single lacing bar. So minimum thickness of double lacing system, double lacing system should be greater than or equal to the length between the inner ends of connections. Maybe I can say from here to here L by 60. But here in these two options, they are saying about the single lacing system. When they are saying about the single lacing system, directly it is the answer is L by 40. When they are saying it as double lacing system, then in such case I need to write L by 60. Why I can reduce the thickness of the lacing bar in double lacing system? Because to resist the transfer shear, there are two lacing elements are there. So for single lacing element, I can for single lacing element I can reduce the thickness. So based on that common sense, they had clearly mentioned it as it should be, here it is 60, here it is 40. That is how you can easily memorize your answer, brother. So is that okay, dear Arjun Yadav, Bianca, Samantha, or any other person who are on the online, Shashi Komit Reddy? So shall I move to the next class? I mean next question, I mean to say, right? Moving to the next question. Right. So moving to the next question, the permissible bending stress in slab base. What is the permissible bending stress in slab base, brother? This is, they are saying directly some values when Fi is 250. So when Fi is 250, so there are two things as per old code and as per new code. In old code, the permissible bending stress of slab base is independent of grade of steel. For any grade of steel, the permissible bending stress in slab base is 185 megapascal. This is as per old code, which is IS 800 1984. But as per new code of practice, if you see, the permissible bending stress of slab base is Fi by factor of safety. What is the factor of safety? When yield stress is governing the design. When yield stress is governing the design, which is 1.1, which is 227 roughly Newton per millimeter square. This is as per new code. But there is no option of 227. Only the option is 185 is there. So this question is completely as per our old code of practice. Directly you can pick option B itself is the correct option. Is that okay, brother? And I want to convey in old code of practice, the element which doesn't depend on the grade of steel, the type of permissible stress is the permissible bending stress. Permissible bending stress. And moreover, I want to convey this as old code of practice because they use a terminology called as permissible. Permissible terminology is a terminology that is used in working stress method. If they want to ask as per limit state method, they instead of this permissible terminology, they may have used design bending stress. So this is the design stress. This is the permissible stress. That is the difference between old code and new code. Old code is based on working stress method. New code is based on LSM method, limit state method. Is that okay? Vignesh Ram. Hi brother, how are you? After a long time again, I am able to see you, Vignesh. Right? Shall I move to the next question, brother? Right? So the option for this one is option B. Dear Bianca, Samantha, Arjun Yadav. Is that okay? Shall I move to Vignesh Ram or any other person, all persons, Shashi Komet Reddy, all, Vasant Sai, okay. Shall I move to the next question? Right? Yeah, moving to the next question, brother. Right. I hope you are able to see which one of the following is a compression member. You tell me which one of the following is a compression member correctly. Purlin. Purlin is a beam. in case of roof truss. Boom is a compression member in case of this is a beam in case of roof truss, and boom is a compression member in case of principal crane system, right? So compression member in crane system, principal compression member in tie is a tension member. Tie is a tension member in case of roof truss. Girt is also a type of beam, right? So if you take out of these, so I didn't show, says I didn't show like make a tick mark. Sorry, I can say the correct option is B for Boston, because it's a following compression member. Two beams and one tension member, one compression member. So which of the following is a compression member, they are asking. So boom is a compression member. Directly we can say that boom is a compression member. So I can pick option B itself is the correct option. So shall I move to the next question, brother? Right? Yes. Moving to the next question. I hope you are able to see the next question. When the battening is preferable, when the battening is preferable, I hope in case of built up columns, two types of tying systems are there. One is built up laced column. Second one is battened columns. When you can go for this tying system as laced column lacing, the tying system we can go for lacing. When there is eccentrical loading is acting, then I can go for this laced system. When eccentric loading is acting, when no eccentric load is acting, that is here eccentric loading means axial load plus moment, here only axial load, right? So no eccentric loading, only when there is axial load, then I can use this battened column, right? And I can say when column carries, I can definitely say like when the space between the two components is I can, this is one, this is one, and I can use this battened column when the spacing between the rolled sections of column are less. In such case we can provide with the help of batten, right? So we can go for battened columns in this case. We can go for laced columns in case of eccentric loading when there is moment also. So shall I pick when the battening is preferred? When column carries axial load only. Yes, when there is only axial load or there is no eccentric load, in such case I can prefer battening. Yes, this first option is correct. I mean first statement is correct. Coming to the second statement, the space between the two main components is not very large. The two main components means the two rolled sections. The spacing between the two rolled sections is not very large. In such case, these two rolled sections are connected, are tied together with the help of plates called as batten plates. Yes, in such case I can go for this batten plates. There is no doubt at all. Even second option is also correct. Sir, how eccentric loading acting on lacing column? Dear, eccentric loading, how eccentric loading acting on lacing column? Okay, let me show you, brother. In case of, let us suppose, if you take these two, or maybe you take this system as a lacing column, brother. You take the system as a laced column. Now this is the column in case of a roof truss. Inside that roof truss I need to keep an aeroplane. The spanning between, this is how the roof truss is. The spanning between this column and this column is almost 30 meters, right? Almost 30 meters. The load is directly coming on this column. The column cannot be directly resting on this the beam here cannot be resting on this column directly. So in such case, if this is a column, right, so over that column, the beam is resting on this column with the help of a bracket plate. I hope you can say this is a column which is composed mainly by two two different element, two rolled section. This is one rolled section, this is another rolled section. So with the help of a bracket connection, we are connecting, we are sending this what you call, we are sending this reaction here. If their load P is coming here, This is the CG of the centroid of the this is the CG of the what I can say, this is the CG of the built up column section. Then in such case, this is eccentricity E. So when this is eccentricity E, right? So this is how the load is coming here P. These two are connected with the help of a bracket plate, because the load from the beam or the load from the truss will come onto the column with the help of a bracket plate. Now I hope you understood how this eccentric loading will act on this column in case of this laser system. Have you understood? Especially if you take any type of key beam column junction, no beam column junction is actually concentric. Most of the beam column junctions are eccentric only. So most of the things generally we can design directly by bat end system. It's obvious, directly we can mention that. Is that okay? Right. Right. So you can say first statement is correct, second statement is correct. Battening is preferred when column is eccentric loaded. No, when column is eccentrically loaded, I can go for lacing system, right? So this is wrong, right? So option 1 and 2 are correct. So I can say C, option C is correct. Is that okay, dear Vignesh Ram brother? Bianca, Samantha, Arjun Yadav. Can I can I move to the next question, brother? Right, moving to the next question. Can you see this question? The maximum slenderness ratio of compression member carrying both dead load and superimposed load, dead load and live load. So the maximum compression, maximum slenderness ratio, this I had already talked. Dead load and live load. The superimposed load is live load. The limiting slenderness ratio for compression member is 180 in that particular case. I had already mentioned, right? So directly I can go for 180. Moving to the next question. So I hope you are able to see the next question. The maximum slenderness ratio of a steel column, right? The maximum slenderness ratio of a steel column, the design of which is governed by wind or seismic forces. When it is governed by wind or seismic forces. So what is the limiting slenderness ratio for a steel column when the compression force is coming into picture because of wind action or seismic forces action? In such case, it is 250. This also I had already mentioned in your previous slide, right? Yes. So moving to the next question, brother. Right. So can you see this question, brother? Is that okay? Right. Vignesh Ram, it is not 350, it is 250. I am not talking about tension members, brother. The limits for tension members are different. The limits for steel column is a compression member. For compression members, the slenderness ratio limits are different. Brother, in your last class, I teach you the limits for tension member. These are for compression members, brother. The compression members limits are different, brother. So, Vignesh Ram, please understand the difference. Okay, this is a compression member, not a tension member. Okay, right. So coming to the next question, right. The compression members, I hope you are able to see, compression members composed of two channels kept back to back and separated by a small distance. Compression members composed of two channels back to back. This is a channel, for example. This is another channel. Oh, 1 second. Right. Right. So compression members composed of two channel sections back to back. Okay. Maybe if I want to show you the same stuff, this is in front view. I can show the same stuff in plan like this. This is a channel section. This is another channel section. Back to back are connected together by riveting so that the minimum slenderness ratio of each member between the connections. These two, so the slenderness ratio of members between these two are connected, tied together. Let us suppose with the help of lacings, like with the help of lacing elements. Maybe I hope you can say with the help of lacing element. This is how these are connected with the help of rivets. Maybe one rivet or two rivets. It's up to you. I don't have any bothering. Right. Now, as this is under compression, this is PU. Now, so that the minimum slenderness ratio of each member, what is the minimum slenderness ratio of each member between the connections? This is one connection and this is the other connection. The slenderness ratio lambda of this individual element, maybe this first element between these two connections, maybe I can say lambda of individual, which I can take as L by R minimum of individual channel section or single channel section. This should be less than or equal to 0.7 times of lambda of built up column. This is built up column. This is one thing. Should be less than or equal to 50. So out of these two, they are talking about the minimum slenderness ratio of each member. So when you take for single element, the minimum slenderness ratio should be less than or equal to 50. So directly I can say it is option directly is B for Boston. Is that okay, brother? Directly I can say B for Boston. If I keep higher gap between these two, maybe these two riveted connections, if I keep higher gap, in such case the spacing of these lacings are more. In such case, when the spacing of these lacings are more, there is a chance like this element between the two restraints are able to what I can say buckle in this way. In order to stop buckling of this local components in between the restraints, there is the limiting slenderness ratio. So there is a limiting slenderness ratio is provided on individual elements between the spacing of the lacing system also. That value of this limiting slenderness ratio lacing system, it should be less than or equal to 50. So directly, sir, why you consider lacing system? Bianca, sir, why you consider lacing system? Even you can consider batten system also, brother. So maybe if you had any doubt, you can take this is a, so this is in case of compression members which are composed of two channels back to back. Either you can take a batten system also, brother. I don't have any objection. You can go for a batten plate here. Maybe you can go for a batten plate here. Generally it will be given with boltings here. Here boltings or rivets, whatever that may be. What is this one? This is nothing but the spacing of the battens. See, this is nothing but this is L is equal to, this is spacing of the lacing bars. This is spacing of batten bars, spacing of batten plates. So in between these two spacing only the element can buckle. The individual rolled column can buckle in between these two. When the spacing is more in between these two, the individual rolled column can buckle. In order to stop that buckling, the slenderness ratio, I cannot say minimum, man. Here I should say the maximum. Maximum slenderness ratio of each and every element, individual element between the constraints or between the rivets should always be less than or equal to 50. So the maximum value is 50 directly. So I can keep option B. So this, why we are doing this one? To prevent or to stop local buckling failure of elements. Local buckling failure of elements. So the buckling can happen between two batten plates or between two lacing bars. It's up to them. But slenderness ratio of individual columns or individual rolled section, this individual rolled channel section should always be less than or equal to 50. Is that okay, dear Bianca Samantha? Why we are doing that one? In order to stop or prevent local buckling failure between the constraints of that rolled channel section in case of columns. Is that okay? Your Bianca Samantha, is that okay? Right? Shall I move to the next question? Your Bianca Samantha. Right? Moving to the next question. So can you see this question? This question I had already tackled. If you memorize or don't memorize, I had already tackled this question in summary of IS 800 part 2. If you take the tacking rivets in compression plates not exposed to weather, it is not exposed to weather, having a pitch not exceeding 300 millimeter or 32 times of thickness of outer plate, thickness of plate. So I can say directly the option is directly option C. Directly we had worked out this. I had already worked out in part 2. Same question again I had taken, because this type of question was asked so many times in different competitive examinations. Right, moving to the next question. Is that okay, dear Bianc Samantha? Right. So can you see this Bianc Samantha? What is this? Vignesh Ram or any other person like Shashi Komet Reddy or all the persons who are on the online. Please respond if you know. Okay, right. So what is the effective length of the column shown below? Here it is a hinge. At this end it is hinge. It is a horizontal shear hinge here. So if you want to sketch the deformation sketch of this one can be in this way. See the deformation sketch. So if you want to draw the qualitatively the bending moment diagram, can be in this way. This is the zero bending moment point. What is the effective length? Distance between points of two contraflexure points, or distance between two zero bending moment points. One zero bending moment point is here. Where is the other zero bending moment point? To get the other zero bending moment point, I need to take a mirror image of here. If I take a mirror image of here, it will be in this way. So directly you can take, this is the second bending moment point, second zero bending moment point. This is first zero bending moment point. The distance between these two is termed as effective length, which is, this is L plus this is already L. So L plus L, it is 2L. So directly the option is, so in case of this one, what is the answer for effective length of the column, brother? The effective length of this column is directly 2L. Is that okay, dear Samantha? Dear Bianc Samantha? Vignesh Ram, is that okay? Right? Can I move to the next question? Is that okay? Right. Moving to the next question. So, what is the use of tie plates? Tie plates means battened plates. What is the use of battened plates in laced column? In laced column, why we provide this battened plates also? If you take laced column in this way, generally the laced columns are in this way. This is how the lacing is provided. After the lacing was provided in this way, at the top, at the ends of the column, definitely I need to provide the battened plates like our tie plates. At the ends I need to provide this tie plates, maybe this way. This is one tie plate, and at the end here I need to provide another tie plate. Right. The use of tie plates in lacing columns is prohibited, is not prohibited, it is not prohibited, brother. Na? So I can say it is permitted at the start and at the end of the lacing system only. So it is permitted at this is start and this is the end of the column. Right. So these are batten plates, I can say. Batten plates are tie plates. Right. So batten plates and tie plates are provided at the start and at the end of the column. So I can say option C is the correct one. Right. Right. So shall I move to the next question, brother? Okay. Moving to the next question. So if you see the next question, the gusset plate is provided in column basis connection. Why gusset plate is provided in column basis? Like in gusseted base, if you take, this is a steel column. To this steel column, between steel column and column base, the name of the column base is, maybe I can take it as, this may be gusseted base is here in this way. This is a gusseted slab base. Between gusseted slab, this is gusseted base. Gusseted slab base. Between gusseted slab base and this main column, we generally provide a gusset plate here, and we provide the gusset plate here. Why we are providing these gusset plates here? What is the reason? If I provide gusset plates, what is going to get happen? I can say this, what is this one? This is nothing but overhang, I can say. Right, the overhang length will get reduced. So by providing gusset plate, in gusseted base, the overhang of gusseted slab base is reduced. When the overhang of this gusseted slab base is reduced, then obviously I can say bending moment M, which is coming into picture because of this pressure from the foundation on this gusseted slab base. When this overhang, see the overhang, when this overhang is less, then obviously the bending moment that has got developed here, which is just at the junction between the gusset plate and this gusseted slab, that bending moment will be reduced. So M max will be reduced. When the developing bending moment is reduced, then I can keep a lesser thick slab base plates itself are sufficient. Lesser thick slab base plates itself are sufficient. That's the reason why generally we will provide this gusseted plates. Gusset plate. This is gusset plate. That's the reason why we provide gusset plates, right? So to reduce the thickness of the slab base by reducing the overhang line. So I can say directly that the option is option B, and I can say, and it reduces the pressure that come. It reduces. This is I can directly say it will reduce the thickness of this base plate by reducing the overhang length. Directly you can keep that, right? So directly the option is option B. Is that okay? Here, Bianca, Samantha, is that okay? Shall I move to the next question? Right? Right. Moving to the next question, brother. So we completed the columns. So right now we came down to beams. So in these beams, I hope you are able to see the allowable shear stress in the web. I hope you are able to see the allowable shear stress in the web of mild steel beam increases with. So if you take allowable shear stress, so at our permissible shear stress, we can say shear stress in the allowable shear stress or permissible shear stress decreases with if you take in web permissible shear stress in web decreases. When the permissible shear stress in web will decrease, and the slenderness ratio of the web is increasing, that is slenderness ratio of the web is almost like depth of the web, like h by thickness of the web. I can say tw when h by tw or d by tw, which is equal to h by tw of the web is increasing, then obviously the web will buckle and will fail. In such case, the permissible shear stress in the web will definitely get reduced. There is no doubt at all. So in such case, by increasing in h by d ratio, not increasing in height, by increasing in h by d ratio, indirectly it is the slenderness ratio of the web we are increasing, right? So directly I can write increase in h by d ratio. Is that okay, brother? Bianca, Samantha, Vignesh, Ram, brother. Okay. Arjun Yadav or Shashi Komat Reddy or any other Vasant Sai or any other person who are on the online, all the persons who are on the online. Is that okay, brothers? Okay. Is that okay, brothers? So can I move to the next question, brothers? Okay. Moving to the next question. Right. And generally I can say there is no, some people had a doubt like, sir, till what slenderness ratio in case of old code of practice, in case of new code of practice, till what slenderness ratio of this web, till what d by tw ratio, or till what h by tw ratio for web, there won't be any change in permissible shear strength of the web. Like in old code of practice, if you see d by tw is less than or equal to 85, till by the time there is no change in permissible shear strength of the web. The permissible shear strength of the web is 0.4 times of Fy. In new code of practice, this d by tw instead of 85, it was came down as 67. When d by tw is less than or equal to 67, less than or equal to 67, in such case, the permissible shear stress of the web is permissible shear stress of the web is yield strength of the web by root 3 into 1 by 1.1. This is the permissible. I cannot say the permissible stress. Yeah, this is the design stress. Is that okay? This is the design stress. This is the permissible stress. And generally, if you take the new code of practice, has got higher design stresses because it has meet with the actual behavior when compared to the old code of practice, right? So that's the reason why I can say if the value for average permissible shearing stress is 0.4 times of Fy. So the design shearing stress for web is Fy, yield strength of the web by root 3 into 1 by 1.1. Why I take this safety factor as 1.1? When yield strength of the material is governing the design, factor of safety is 1.1 for structural steel. This is how we learned in your previous classes, right? So shall I take the next problem, brothers? Right? Moving to the next problem. Is that okay? Right. So I hope you are able to see this question. The outstand of the flange of a built up beam. So if you take a built up beam, for example, maybe the built up beam, this is a flange plate, this is web plate, and this is flange plate. Where it is a built up beam, generally we will provide the stiffeners also. This is the outstand of the stiffener. I just want to convey you. This is the stiffener that is provided. This is the outstand of the stiffener. This is the outstand of the stiffener. Okay. What is the outstand of the stiffener? If you take, this is the outstand of the flange of the built up column. This is the outstand of stiffener. Outstand of flange stiffener or web stiffener. Outstand of the flange stiffener from the line of connection. This is the line of connection, should not exceed. Can I keep this as 1 kilometer? Even though if you keep this stiffener width, this outstand width of the stiffener as 1 kilometer, it is useless. Only to some extent. Only this is the width of, this is the outstand of the stiffener. What is the maximum outstand of the stiffener? As per old code of practice, the maximum outstand of stiffener, if you take, so if it is B, if B is outstand of stiffener, as per old code of practice, there is no new code of practice. I will say the answer for new code of practice also, don't worry. So as per old code of practice, our maximum outstand of stiffener B should not be more than 256 times of thickness of the flange. I can write thickness of the flange TF by square root of F. This is as per old code of practice. Now coming to the new code of practice, this B, which is maximum outstand of stiffener, should not be greater than 20 times of thickness of the stiffener TQ multiplied by epsilon. The epsilon value is 1. So directly I can say the maximum value of outstand of the stiffener should not be more than 20 times of thickness of the stiffener. TQ stands for, I can say, thickness of the stiffener. This is new code. Okay, so as this question is as per old code now, so directly I can pick option C. If there is no option as per new code, so directly you can directly pick option C, which is based on the concepts of working stress method. Is that okay, Bianca, Samantha, Vignesh Ram? Is that okay? Can I move to, I mean, for every class I am discussing both old code and new code. So can I move to the next question? Is that okay, brother? Right? Moving to the next question, brother. So moving to the next question. I hope you are able to see this question. A cantilever arm. A cantilever arm is attached to a column. If you take a column in this way, a cantilever arm, like cantilever bracket plate, I can say. A cantilever arm or cantilever bracket plate is attached. Okay, let it be attached. Why this cantilever arm is attached? To transfer the beam reaction on the column with the help of this bracket plate. This bracket plate is nothing but bracket plate. This bracket plate, or I can say this is called as cantilever arm. Another name for this is bracket plate, na. So this over this bracket plate, I can say the beam will rest. Beam will rest. The beam will apply a reaction directly on this bracket plate. That reaction will be gone to the column with the help of, maybe I can say definitely with the help of bolting or riveting or maybe welding or anything, I can say. Which one of the following is the best connection? So in such case, when it is a cantilever arm, it is nothing but bracket plate. When it is bracket plate, another name for the bracket plate connection is also called as, I can say another name for this bracket plate connection is also called as end plate connection. You can call this connection as end plate connection also, right? So I hope you can say, yes, the another name for this bracket plate connection is also called as end plate connection. Directly, I can say option D itself is the correct option, right? So I just want to say here, for cantilever arm, both moment and end reaction is to be transferred without rotation, and therefore rigid connection would be the just best choice, and therefore rigid connection would be the best choice. So out of this rigid connection, what are rigid connections? Example for rigid connections are, I can say split beam connection, end plate connection. I can say examples for rigid connections. I can say, what are the examples for rigid connections? I can say first one is end plate or bracket plate connection is a rigid connection. Second one, I can say, is split beam connection. There are examples for rigid connection. So I can pick option D itself is the correct one. But if you take another options, those are some semi-rigid connections, or some are flexible connections also. So I should not take A, B, C options. I can only take option D for Detroit is the correct option, because that option should take care of bending moment also, right? So moving to the next question, is that okay? Right? Shall I move to the next question, brother? Right. Moving to the next question. A steel beam is connected to a steel column. I hope you can see a steel beam is connected to a steel column by means of two angles placed on the two sides of the web. So if you take a steel beam, right, a steel beam is connected to a steel column. This is a steel beam. This is a steel column. The steel beam is connected to steel column with the help of two angles placed on two sides of the web of the beam. This is an angle that is connected, that has got connected on one side of the beam. On the back side of the beam, there is another angle is connected. This beam is connected to column, definitely. This is the column, right? This will be the column. How we can connect between these two? We can connect between this beam and column with the help of two angles which are kept back to back here. Maybe I can say this is how we can connect. This is here, and here we can see this is how, right? What is this? What is the name of this type of connection is called? The name of this type of connection is nothing but framed connection. This is a type of framed connection, you can say. Beam column connection, it is a framed, we can say. So directly I can say it has option C, right? So shall I move to the next question, brother? Right? Moving to the next question, brother. I hope you are able to see the next question in beams. A cantilever steel beam of 3 meter. I hope you can take a cantilever steel beam. Maybe a cantilever steel beam is there. Carries a uniformly distributed load of. It is carrying a uniformly distributed load of 20 kilonewton per meter, inclusive of self weight. Okay, the beam comprises of, it is an ISLB, ISLB, Indian Standard Light Beam. So let me show it's an I section. Let me show it in this. This is an I beam. You take ISLB 200. The overall depth of the section is 200 millimeter. And the flange dimensions are also they are giving. The flange width is 100 millimeter. And thickness of the flange width is 100 millimeter. And thickness of the flange is 7.3 millimeter. And they are saying thickness of the web is 5.4 millimeter. Okay, they are giving bending moment about the bending, sorry, moment of inertia about the major bending axis. It is IX axis. How much, brother? Moment of inertia about major bending axis is 1696.6 centimeter per foot. Here the bending will happen about this axis, right? So they are expecting what is the maximum bending stress. To get maximum bending stress, and it is a single homogeneous material. It is not a it is not a composite material. When it is a composite material, I need to use Euler-Bernoulli's theorem to find out the developing stress, right? Just like that of design of concrete structure. That is a single type of material and is subjected to bending moment. I can say, as it is a homogeneous material, I can use simple bending theory to find maximum bending stress. Find maximum bending stress. What the simple bending theory teaches us? So the simple bending theory teaches us is M by I is equal to F by Y. So I want F. So how I can get this F? F I can write as F maximum stress. Na? M by I. To get F as F max, Y should be Y max, right? So Y max, I hope you can see this is the maximum fiber distance is 100 millimeters, the Y max. Definitely I can write Y max. Answer is how much, brother? 100 millimeter. It is okay. How I can work out M, brother? M, if you take M is equal to P into E. If you take M, if you take, which is equal to P into E, which is 20 kilonewton per meter into this length is 3 meter. 20 into 3, it is 60. So 60 into half, 60 into 1.5, it is 90. So M is 90 kilonewton meter. So the answer is 90 into 10 to the power of 6 Newton millimeter. I hope you can say the value of maximum bending moment is WL square by 2. If you use this formula, directly you are able to get the maximum bending moment, right? W is 20 into 3 square by 2. If you work out, that is 20 into 3 square by 2. The answer of this 90 kiloton meter will come. If it is in Newton millimeter, 90 into 10 to the power of 6. Okay. And what is I value? I about this XX axis. What is the I about this XX axis? 1696.6 centimeter per 4, which is 1696.6. 1 centimeter. How I can write in terms of millimeter? 1 centimeter is 10 millimeter. I can write 10 to the power of 4 millimeter power 4. Directly I can write in this way. So try to substitute everything here. So when you substitute I, when you substitute m here, so definitely you are bound to get the value of f max from this one. Just substitute the value of this m, this value m here, okay, and substitute ixx, this one, okay. Then in such case, definitely you are going to get this value of f max. What is the value of this f max, brother? 530.47 Newton per millimeter square. This is how you can work out this maximum stress, bending stress, 530.47, which is option B for Boston is the correct option. Is that okay, brothers? Is that okay, brothers? Can I move to the next slide? Right? My next question, I mean to say. Shall I move to the next question, brothers? Yes, moving to the next question. Right. So out of these given sections, ISMB, ISLB, ISHB, ISWB, the heaviest I section for the same depth, out of these four profiles of sections, which section is having higher mass or higher density, or I can say higher heavy depth or heaviness or higher mass or higher weight for the same depth? So I hope you know ISHB stands for Indian Standard Heavy Beam, right? Okay, sir. What is major axis? Okay, AER1 Dhaval Shanti. Okay. Answer is D. So you are saying answer is D. Okay. You are saying answer is D. Okay, sir. What is major axis? Please. There is no need to ask that much times. If you say one thing, definitely I will look down that one, brother. See here, we are not going in rush. Everything we will work out in a cool way. I hope what is this major axis means? Major axis of cross section is the axis about which moment of inertia is high. Axis about which moment of inertia is high. Especially in case of beams, when the loading is purely vertically downwards, the bending will happen about this major bending axis. This is major bending axis. This is minor bending axis. About this one, the moment of inertia is less. That is the fundamental concepts of strength of materials, brother. So this is minor axis. About major axis, the bending will happen generally. So about major axis, moment of inertia is high, whereas about minor axis, moment of inertia is less. You can see here out of this and this, about which axis moment of inertia is high. So about that axis, bending will takes place for normal beam. So directly the bending will takes place about IXX. What is IXX? It is the moment of inertia about the bending axis. That's what it means. Okay, right? About bending axis. Is that okay? About bending axis, what is the moment of inertia? The moment of inertia about that bending axis, if it is notation, I am taking it as IXX. It is major axis. So the major axis of cross section and minor axis of cross section I had defined for you, na? AR1 Dhaval Shanti. Is that okay? Can I move to the next question, brother? That is the fundamental stuff what you learned from your strength of materials, brother. That is the fundamental stuff. Okay. Can I move to the next question, brother? Okay. Yeah. Okay. Right. Moving to the next question. So the heaviest I section for the same depth. Don't worry. Don't get panic. Okay. So everything with cool. Everything slow, coolly. आराम से कर लेना भाई, everything we will do it. Okay, so don't worry. The heaviest I section for the same depth. What is ISHB? Indian Standard H for heavy beam. LB, L stands for light beam. MB stands for medium weight beam or medium beam. WB means wide flanged beam. Right? So out of all these sections which are having same depth, generally the heavier weight or heavier mass is for Indian Standard Heavy Beam. Directly it was there in this notation itself. So directly I can go for ISHB for the same depth, for the same cross sectional area. If you take Generally, ISHB has got higher mass or higher weight than other I sections. That's what we can say, right? So can I move to the next question, brother? The option is C. Can I move to the next question? Yes, moving to the next question. Generally, coming to the maximum deflection of steel beam. What is the maximum deflection of steel beam should not exceed? This is as per old code of practice. If it is as per old code of practice, the maximum deflection that we are working out based on service loads. How we can work out the maximum deflection of beam due to service loads? I hope your teacher, SM teacher or SA teacher had already teach you how to find out the maximum deflection in the beam. That maximum deflection by structure analysis program or by SM, strength of materials program, you are able to work out. When the maximum deflection should always be less than span by 325. That means indirectly, that is, it should not maximum deflection because of service loads should not be greater than, I can say, span by 325. So when it is more than span by 325, in such case, serviceability criteria, serviceability issues like excessive deflection may result in cracking and all this stuff. So in order to avoid serviceability issues or durability issues, the maximum deflection that is developing in the structure because of service load should be limited as span by 325. L by 325. Is that okay? This is for I can say steel beams. Okay. So moving to the next question, brother. Moving to the next question. So I hope you are able to see. Consider the following statements. A grillage beam. I hope a grillage base is checked for. So what is a grillage base? I hope you know grillage base is a form of slab base or column base. I mean, it's a form of slab bases only. The grillage base. What is this grillage base is? Let me write the definition. It is not in the portion, but still I just want that this type of question was asked one time. That's the reason why I don't want to even miss this grillage base questions also. What is this grillage base? This grillage base essentially consists of steel beams encased in concrete. When steel beams are encased in concrete, the steel columns are resting on this encased concrete on this encased steel beams within on concrete. If we keep these columns on this one, these steel beams are subjected to bending, shear, and these are subjected to web crippling also, right? So I can say they are provided. One second. When some people had a question like, sir, when, so for dead loads and live loads only, here I can say, let me write when this grillage beam is used. Here we can say when this grillage beam is used, when the soil is weak. Generally in such cases, generally we will use this grillage type of base, one thing. And the load on the column is very high. In such case, I use this grillage beams. So when grillage base is provided as column base, I can say the first and foremost condition or rule is when the load on the column is very high. When the load on the column is very high. Second condition, when the foundation, if the foundation is resting on weak soils, in such case I can use, I mean to say that the bearing capacity of the soil is less. In such case I should use this grillage base, right? I mean service loads for previous question. Dear service loads, okay, you want to mean service loads. What are service loads, brother? Service loads are the actual loads that are acting on the structure. Actual loads or characteristic load. In your limit state method, it is characteristic load. acting on this structure. So I can say it can be dead load, actual dead load acting on the structure, actual live load acting on the structure, actual earthquake load acting on the structure, actual wind load acting on the structure, whatever may be the actual load that is acting on the structure without load factor. That load that has got considered without considering load factor, that load is nothing but service load, I can say, which we people call in the same load in limit state method as characteristic load, in other words. Is that okay, dear Bianc Samantha? Is that okay? Right, it is not just dead and live loads, it is any actual value of dead load, live load, wind load, earthquake load, any load. If I consider the actual load that is developing on the structure, that actual load that is developing on the structure is nothing but service load, right? Is that okay? Right. So when we will go for this grillage base, brother, when we will go for this grillage basis, I can say clearly we can go for this grillage basis when the bearing capacity of the soil on which the concrete block is to be placed may be poor quality, poor safe bearing capacity. In such case, I will go for this grillage beam. This grillage beam will be designed for what forces this grillage beam will be designed for? This grillage beam will be designed for bending moment will come there, shear force will come there, and as these beams are there, the steel beams are there, the steel beams may be subjected to web crippling. So I can say and web crippling, all these three are going to happen. Yeah, these three modes of failure that are possible in grillage beam. So I can say like bending will happen, shear will happen, and web crippling will happen. 1, 2, and 4. The correct option, which of the statement is correct? I can say option D. 1, 2, and 4 statements are correct. Directly we can say, right? Design for bending, design for shear, and design for web crippling. Check for web crippling. All these are three modes that needs to be checked. Okay, that you need to treat just like a beam only. And in beam, these are the failure modes in beam: bending, shear force, and web crippling. Those things generally we will check. Yes, design for bending is the better way, right? So can I move to the next slide, brother? Here, Dhaval Shanti, right? Moving to the next slide or next question. Lateral buckling of beam is not, how the lateral buckling of beam is not prevented? How we cannot stop the lateral buckling of beam? So when you take what I can say, when you take a steel beam, cantilever steel beam in this way, how I can show this lateral buckling, brother? When this is the length, if this when it is attached with a load, for example, right? So because of lateral buckling, let us suppose with respect to this y axis, if you take with respect to x axis the major bending axis, with respect to y it is the minor bending axis. Moment of inertia about this axis is moment of inertia is high, whereas moment of inertia is less. So after it has got deflected vertically downwards after some time, because of its lower bending moment with respect to this y axis, I can say the same beam, because as there is no lateral restraints, because as there are no lateral restraints, the beam will start bending even to the sideward direction also in this way. So if I want to show the deformation sketch, maybe I can show in this way. It has got sufficient, this is how it has got deformed. So directly I can say like, in this way. So this is vertical deflection and this is horizontal deflection. How we cannot stop, how we cannot how this lateral buckling of beam is not prevented by, the lateral buckling of the beam is not prevented by embedding compression flange in this slab. No, increasing, no, they are saying it is not, no. When you embed, this is the compression flange. when you embed this compression flange inside the slab, when it is inside the slab, it won't deform vertically downwards and it won't deform. It is not possible to deform horizontally. So when this delta H is equal to 0 is not possible. Is not possible when I increase the depth of the web. When I increase the depth of the web, like when I increase the depth of the web, when I increase the depth of the web, then in such case, because of buckling action, like shear buckling action, this is able to move to the sideward direction, isn't it or not? They are saying in the saying here with the question called not. This lateral buckling can be prevented. How lateral buckling in beam can be prevented? By providing lateral restraints. How you can provide lateral restraints? By providing lateral restraints with the help of shear connectors. With the help of shear connectors, I can provide lateral restraints. And second one is by embedding the compression flange inside this slab. By embedding compression flange. By embedding compression flange inside slab. And the third way is by providing lateral bracing. See if there is a one beam and there is another beam. Not to stop this horizontal or lateral displacement. If I had gone for bracings in plan, this is bracings in plan. If I had provided for this cross bracings in plan between these beams, in such case also by providing lateral bracings, we can stop this lateral deflection or lateral buckling. So I can say by providing lateral bracing elements, cross bracing element, lateral cross bracing elements. Okay, so by doing all these three, we can stop this lateral buckling of the beam. We cannot stop lateral buckling by increasing the depth of the web. By increasing the depth of the web, shear buckling is possible, and in such case it is subjected to lateral buckling again. So this option D is the correct option for this question. This is how. Sir, explain shear characters, how it is used. Definitely, brother. Let me show you. Here is all the. I hope, and this is a slab, brother. This is slab. And this is slab, and this is an I section. And this is an I beam, which is kept here. When this inside this slab, between the slab and between this I section, I beam or beam, between these two things, if I had gone for a connector with the help of some studs in this way, with the help of studs in this way, these are nothing but shear connectors, okay, which stop the lateral buckling of beam by connecting compression flange and slab together with the help of shear connectors. Is that okay? This is concrete slab. Inside that concrete slab, this is just kept beneath. Between these two, if I had gone for some type of shear bolts in this way, in such case, this and this will act together. Such are nothing but, these elements are nothing but shear connectors. The shear connectors may be mostly like bolts, we can say. Is that okay, dear Dhaval Shanti? Can I move to the next question? Is that okay? Right? Moving to the next question, brother. A steel beam supporting loads. I hope you are able to see. A steel beam supporting loads from the floor, slab, as well as from wall. A steel beam is there which is supporting loads. A steel beam is supporting loads from the floor slab as well as from the wall. So if you take a floor beam, this is a type of floor beam, which is taking some amount of slab. This is slab load. Over the slab there is again wall. This is wall. This is the beam which is supporting floor load and wall load. What is the name of the beam which is supporting both the floor load and wall load? The name of the beam which is supporting floor load and wall load is nothing but spandrel beam. It is nothing but spandrel beam. Directly we can see, right? I hope you know lintel beam, a beam which is supporting at the lintel level, right? A beam which is supporting the opening of the doors and windows above the wall. Such type of beam is nothing but lintel beam. And stringer beam. Stringer beam is a beam which supports the staircase, which supports the staircase. That is nothing but a stringer beam, right? So this option is C. Moving to the next question, right? So I hope you are able to see the next question, brother, right? So for a cantilever beam of length L, built-in support. A cantilever built-in means built-in support means I can say fixed support. Fixed, I can say. Fixed and restrained against torsion at the free end. So it is one end is fixed, and at the other end of the beam it is restrained against torsion. How it can be restrained against torsion? By providing with the help of a torsional spring. This is a torsional spring. Let us suppose a torsional spring is attached. In such case, the effective projecting length. So here at this end it is free, but only it is not free to twist, but it is free to move vertically downwards, but it is free to move horizontal, to move in horizontal direction, but it is not free to get twisted. That's what it is the meaning. And the actual length of the beam is L, right? Actual length of the beam is L. In this case, for this type of beam, okay, what is the effective projecting length? The effective projecting length, if you take for this beam, is, if you refer to the code of practice IS 800 to 8800 1984 and even 2007 also, there are several conditions were given based on the effective length for beams. The effective length for this type of beam is 0.75 times of L. This is 0.75 times of L. So maybe I can write, if you see, the effective length in this case is 0.75 times of L for this type of beams. So shall I move to the next question, bros? Moving to the next question, brother. I hope you are able to see this next question. Under a concentrated load, the bearing stress FB in the beam. What is the bearing stress FB in the beam? So maybe where the bearing stress will come, let us suppose this is a beam, brother. Bearing failure, another name for bearing failure is also nothing but web crippling failure indirectly. Web crippling failure. When it is web crippling failure, generally if this is the, if the width of the support is B, from this one, under this one, a heavy compression load may go in this way. Or if a heavy point load is applied, here maybe this is the point load P and this is P. So in this direction at some angles here, some dispersion in load will takes place. I can say if you take a beam of I section or anything, generally where that web can happen, web crippling failure will happen at the level of root radius. So at the level of root radius, maybe here, this is level of root radius. If h is the depth, including the thickness of the plane and root radius, if h is the depth, for example, if h is the depth, I say, maybe 1 second, if h is the depth, right, maybe here also if h is the depth, right. Now this angle of this dispersion of this load because of heavy concentrated compression force from flange to web placed at an angle of 1 vertical to √3 horizontal as per old code of practice. As per old code, 1 vertical to root 3 horizontal. This is already B. This is already H. So this is root 3H. So this is root 3H. So what is this width? Over this width only, we are able to see that web crippling. The web crippling width is B plus 2 root 3H, I can say. Right? Now that web crippling will happen over a thickness of TW. So what is the area over which that web crippling will happen? Web crippling area, it is equal to web crippling width, which is B plus 2 root 3H root 2H root 3 or 2H root 3H into thickness of the web. Now if you are expecting the bearing stress or web crippling stress, how we can write that web crippling stress as per old code of practice? See, this is as per old code of practice. As per old code of practice, web crippling stress or bearing stress, how we can write it is the bearing stress is coming into picture because of this load P or W. You can take P or W. If I take it as W by that web crippling area, or what is that web crippling area? B plus 2 root 3H times of thickness of the web. This is as per old code of practice. Now as per new code of practice, if you want to work out, how I can work out as per new code of practice, let me write here. As per new code of practice, the value, the B is B, P is P, and everything is there, but the load, the angle at which this load dispersion will happen will, in case of this new code, is at an angle of, if you take the load dispersion will happen at an angle of 1 vertical to 2.5 horizontal. So if this is already B, at the level of the throat thickness, I can say this width is B plus, this is already 2.5 times of H, this is already 2.5 times of H. So I can write B plus, I can write 2 times of 2.5 times of H I can take. Right? So as per new code of practice, it is W by B plus 2.5 times of H into 2, I can write, into thickness of the web. This is how, as per new code of practice, we can work out the crippling stress or bearing stress in case of beams with heavy when it is applied with heavy concentrated load. Is that okay, brother? Dhawal Shanti, is that okay? Dhawal Shanti or any other person who are on the online, brothers, is that okay? Yes. Yes, good noon. Ambar Datta, how are you, brother, after a long time? Yeah, again, I am able to see you after a long time, brother, Ambar Datta, bro. Dear Ambar Datta, bro, I just want to convey one more thing. I taught you in your previous classes about new code of practice. In these sessions, I am even working out the clauses of old code of practice also. Both I am comparing old code of practice and new code of practice for the same specification. I am comparing and teaching. I can recommend you, dear Ambar Datta, especially Ambar Datta, bro, please go through these sessions also, because this is as per old code of practice, because working stress method of concepts, especially if you go for JE exams, SSC JE, or maybe PSU examinations, even the questions are asking from working stress method. In such case, that is required for you. May not be GATE that much, but for other exams like ESC, SSC JE, or maybe PSU examinations, even working stress method questions were asking like anything. So I can recommend you even this one also for those questions other than GATE. Okay, right. Okay, right. So as for today, brother, the I can say time is already going to get up for today. So please excuse me, like I am just trying to wind up the session. Before I wind up the session for you guys, I am saying, like, if you want to join the paid course in Unacademy learning app, either plus course or subscription, either plus course or iconic course, for any of the course, if you want to get 10% discount, then use this code VD10 in Unacademy learning app to get 10% discount on all courses in Unacademy Plus platform. Even coming to the plus courses in Unacademy Plus, the cost for 12 month subscription after 10% discount is 27,225. I can recommend this 12 months subscription course for the students who are in final year. If you are a student who are in third year or second year. In such case, I can recommend you guys with this 24 months course for third year students or second year students. So they will have some ample time and they can work out very, very coolly. And the duration of subscription is 24 months subscription course. The cost is 39,600 after 10% discount. If you want to get any discount, 10% discount for any duration subscription, for 1 month subscription to 24 month subscription, you are bound to use this code VT10, brother, no doubt, in an Academy Plus platform, right? And I can say, if you want to follow me in Unacademy learning app, after you install Unacademy learning app, use this link. If you are able to use this link which is given here, then directly you are able to follow me. If you are able to follow me, the advantages for you are already done free content by me. You are able to access the future coming free video lectures of mine will be notified to you. The free notes that I give at the end of this session, especially for plus, especially for free sessions in the app, will be given to you. These are three you are getting. You are getting all these three as advantages when you are able to follow me without losing even a single penny, right? And I just want to convey, every day my class is happening in this Let's Crack GATE and ESE Civil YouTube channel. My class is happening every day by 11 a.m. I'm teaching structures there, and you can follow Kamalakar Sir Pandey's class also. He is teaching non-structures. I can recommend even Kamalakar Sir Pandey's classes also every day. His class is happening by 9 a.m. right? And I just want to convey one more thing, like please, you are getting all this for free of cost. Please subscribe to this channel. Please subscribe to this channel. Please share this video. Please like this video, because with lot of pain we are doing this for you, right? And please share this video to your friends so that they will also get benefited. Please like this video. Please share this video. Please subscribe to this Let's Crack GATE and ESE Civil YouTube channel, right? So that you will not miss even a single video that is coming in this channel. Don't forget to press the bell icon. If you press the bell icon, future notifications of future coming videos will be notified to you. And the name of the Telegram group is also one and same. Please join this Telegram group, Let's Crack GATE and ESE Civil Telegram group also, and you will be notified with the future coming lectures. For you guys, personally I had started a Telegram channel, and the name of the Telegram channel is, that is also an Unacademy channel only, Unacademy_Civil Engineer Tilak. If you are able to come down to this channel, you are able to ask any doubt, and I can reflect. I can resolve all your doubts, brother, if you come down to this channel. And moreover, I can say, like, how some people will say, like, sir, how we can come down to this Unacademy_Civil Engineer Tilak channel? Use this link which is given below, Unacademy_Civil_Engineer Tilak. Use this link below. After installing the Telegram app, use this link below. When you come down to this link, when you press this link, you guys will be redirected to my channel. Okay. So don't forget to press the thumbs up, brother. Please raise a thumbs up. Please share this video. Sir, do you play chess? Dear brother, I don't play chess, brother. I don't play chess. Okay. It's okay. So please excuse me. Please, guys, please share these videos to your friends also, so that they will also get benefited. Thank you very much. Thank you. End of the session.